Okay, today we're going to be continuing with section 1.8 dealing with inequalities. Last class we looked at linear inequalities and polynomial inequalities, and today we're going to be looking at rational and absolute value inequalities. Okay, so a rational inequality is going to look like this, where it has a numerator and a denominator. We're actually going to follow a lot of the same steps that we used with our polynomial inequalities as far as setting up cut points and intervals and so forth. So a lot of this will be the same. So the first thing that we want to do is we want to find our test points, and we want to do that by setting the numerator equal to 0 and the denominator equal to 0. Okay, so we're going to set x minus 2 equal to 0, and we're going to set 3x plus 1 equal to 0. So we're going to get x equals 2 and x equals negative 1/3. Okay, so these are our cut points here. So we'll have negative 1/3 and we'll have 2. One thing you have to be more careful about with rational inequalities is you have to make sure that the denominator is not going to be equal to 0, because that's going to give you a division by 0 error. So the value that makes this equal to 0 is this negative 1/3. So we need to be sure that we're going to exclude that, and it's not going to be included as part of our answers when we give this. Okay, so this is divided this and cut this into 3 intervals. The first interval is negative infinity to negative 1/3. We have negative 1/3 to 2, and then we have 2 to infinity. Okay, so a test point here might be negative 1, here may be 0, and here may be 3. Okay, so we're going to take the x minus 2, and we're going to take the 3x plus 1, and then we're going to take the 2 together. Okay, so if I plug my test point in here, I'm going to have a negative. If I plug it in here, I'm also going to have a negative. And so a negative divided by a negative is going to give me a positive. If I plug 0 in, I'm going to have a negative, and then I'm going to have a positive plugging it into this one. And then if I divide a negative by a positive, I'm going to get a negative. If I put 3 in, I'm going to have a positive divided by a positive gives me a positive. Okay, so looking at this, I've got greater than or equal to. So because it's greater than or equal to, I need my positive regions. So my positive region is going to be this region and this region. So going back and remembering that I cannot include the negative 1/3, my interval is going to be from negative infinity to negative 1/3 with a parenthesis on the negative 1/3. And then I'm going to union that with this other interval over here. It's going to be from 2 to infinity. And because the 2 is not coming from the denominator and I have this bar here, I'm going to actually put bracket on that, because 2 would be fine. If I put 2 in here, 2 minus 2 would be 0, and it can be equal to 0. But if I put negative 1/3 in, then I have an undefined expression. So it can't be equal to negative 1/3, but it can be equal to the 2. Okay, this is one that is not already equal to 0. So what we're going to have to do is we're going to have to move that over. So we're going to have 1 plus x over x minus 1, subtract the 1, and that's going to be greater than or equal to 0. So what we need to do before we can analyze this, we need to get it in fraction form. So we need to get a common denominator. So if I look at these two, my common denominator is going to be x minus 1. So I need to multiply this by x minus 1 so that I have that common denominator. So when I combine it together, I have 1 plus x. I'll distribute the negative. So I'll have negative x plus 1. and all these are greater than or equal to 0. So here I'm left with 2 in the numerator and x minus 1 in the denominator. Our cut points. If we go to set the numerator equal to 0, then we really don't get anything from that because we know that 2 is not equal to 0. And then if I set the denominator equal to 0, then I'm going to get 1 as my cut point. So I only have one cut point here. That cut point is at 1. And because it's coming from the denominator, we actually can't ever include that as part of our answer. So our intervals will be from negative infinity to 1 and then from 1 to infinity. And our test point, we could let 0 be a test point here and 2 be a test point here. So we've got, you don't go back in a case like this and plug it into the original. You need to actually go to where you have it simplified and compared to 0. So I'm going to have 2, and then I've got x minus 1, and then I've got 2 over x minus 1. So 2 is obviously positive regardless because there's nothing to plug in there. If I put 0 in, I'm going to get a negative. So positive divided by a negative is going to be a negative. When we plug the test point in for this interval, if we plug 2 in, there's nowhere to plug it in. So 2 is always positive. We're going to plug the 2 in here. This is also positive. Positive divided by a positive is a positive. So if I look at this, I actually need, comparing here, I need the greater than symbol. So greater than means I need the positive region. So it's going to be this region here. So my answer is going to be from 1 to infinity. Okay, looking at this next one, we're going to kind of proceed in the same way here. We need to get everything pulled over so it is compared to 0. So we need to also get a common denominator. So x plus 1 would be the common denominator. So we'll have to multiply this by x plus 1 over x plus 1. And then we're going to have x minus 3x minus 3. And then that's going to be over x plus 1. So we'll have negative 2x minus 3 and x plus 1. So we'll get our cut points by setting the numerator equal to 0. So we're going to get negative 3 halves for one, and then for the other one, we're going to have negative 1. So we have a cut point at negative 1.5, which is negative 3 halves, and also at negative 1. So our intervals here are going to be from negative infinity to negative 3 halves, from negative 3 halves to negative 1, and then from negative 1 to infinity. So this one, we could have negative 2 for our test point. This one, we might have to have like negative 1.25, and then this one, we could have 0 for our test point there. Okay, so we're going to be putting it into, again, go down to where you have it simplified and then compared to 0. Don't use this one. So we're going to have negative 2x minus 3 and x plus, take that away, okay, and then x plus 1. And then we'll have negative 2x minus 3 divided by x plus 1. If I plug negative 2 into this one, I'm going to have a positive. If I plug negative 2 in, I'm going to have a negative. Positive divided by a negative is going to give me a negative. If I plug this in, I'm going to get a positive. If I plug this in here, I'm going to get a negative. So I'm going to end up with a negative. Actually, I'm going to back up just a bit, and this one would, this one would be should be a negative, and this one should also be a negative, so this is going to be a positive. So just be really careful with this and keep track of your signs. It's easy to make mistakes with that. So if you're putting here, if we're putting 0 in, then we're going to have a negative. If I put 0 into the denominator, here, we're going to have a positive. So a negative divided by a positive is going to give us a negative. So in determining which interval to choose, we're going to look back over here at this one, and we want greater than 0. So greater than 0 is going to be the central interval here. And so we're going to have from -3/2 to -1. Okay, this is the graph for the one that we just got through finishing up. So our answer on that one, if you recall, was from -3/2 to -1. So if we look at this, our answer here, you can see that here is our -3/2 and here is -1. So it's a very small part of the graph, but this is the part that is above the axis, this part here, and that is that positive part that we needed to locate. So the graph does correspond with the answers that we gave. Okay, here's another one that we want to take a look at. Okay, on this one, we've already got it set greater than 0, so we can just go ahead and proceed to getting our cut point. So we've got 3x plus 15 equals 0. From this, we're going to see that our cut point is going to be -5. And then here x minus 10 equals 0, so 10 would be our cut point there. So when we set this up here, we've got a cut point at -5 and a cut point at 10. So our intervals would be -infinity to -5, -5 to 10, and 10 to infinity. Okay, so a test point here might be -10, maybe 0, and maybe 20 for this one. So when we plug these in, we've got to plug into 3x plus 15 and x minus 10, and then we've got to plug into this. Okay, so in the first interval, if I'm putting a -10 in as my test point, then that's going to be -30 plus 15 is going to be positive, negative. Negative. If I put -10 in, then I'm also going to be negative. Negative times negative is going to give me a positive for this region. If I look at plugging 0 in, 0 is going to give me a positive and a negative. Positive divided by a negative is going to be a negative. And if I put 20 in, I'm going to have a positive and a positive. So positive divided by a positive gives me a positive. This one is greater than, so I'm looking for the positive region. So that's going to be this one and this one. And I don't have a bar underneath here, so I really don't have to worry about whether to include my cut points because they're not included anyway due to this. And so I'm going to give my answer as -infinity to -5, union that with 10 to infinity. So my answer as far as the graph goes, I'm going to have an open circle and sketch back this direction. And then I'm going to have 10 and go in this direction. While we're talking about this, just kind of as a side note, if I had 3x plus 15 over x minus 10, and I had that less than or equal to 0. So if I change it around a little bit, this one, then I need to take the inside part here from -5 to 10 because I would be needing the negative region. And I would need to exclude the 10 because of it being in the denominator. So I would put a parenthesis on that, but the -5 would be okay. So I would put a bracket on that. So that was just kind of a little side note, just to kind of have another reference so that you could see that if you're turning this around, how it's going to affect your the endpoints and so forth. Okay, the last type of inequality that we're going to look at is the absolute value inequalities, and these are some of the easiest ones to do. If we look at these absolute value inequalities, we have different properties here, but I think I'm just going to go ahead and go through some of the examples with this. If we look at this, we're going to divide it into two cases. The first case is those that have an absolute value less than something. So if it has an absolute value less than something, those are going to be what we consider to be the and problems. And one way to remember that is you've got the less than sign. So than is going to, like and here. So you're going to make those into a compound inequality because it's saying that it's two things combined together. So it's going to be a compound inequality. The way that we write it as a compound inequality is we take this middle part, or we take the part in the absolute value and put it in the middle. And we're going to put less than signs around it. And then we're going to take the 5, and we're going to put the negative 5 over here. And that goes back to the fact that the absolute value of, say, a positive 4 and a negative 4 are both equal to 4. And so we have to account for both the positive case and the negative case there. So we're going to add 4 to both sides because we've practiced solving these compound inequalities before. We'll have -1 is less than x is less than 9. So our interval is going to be from -1 to 9. Okay, here's another one to practice with. This is a less than, so we'll do x minus 5, less than signs on either side, and we'll have -2 and +2. So we need to add 5 to each part. So we'll have 3 is less than x is less than 7. So it'll be from 3 to 7. Here's one for you to practice. If you'd like to pause this and practice it, go ahead and do that. Okay, you'll put the part in the absolute value in the middle, and we'll put the -4 and the +4 on either side, and then we're ready to solve. Subtract the 2 first. We'll divide by 3, and we're going to get -2 is less than x is less than 2/3. So we'll have -2 to +2/3. And these would be done the same way if they had less than or equal to's. It just so happened that all of our examples were just strict. Okay, the second case we're going to call the greater case because it's the greater than symbol, so greater. We're going to have to write this as two separate inequalities. So for the less than, which is the and case, you write it as a compound joint inequality. Here for the two separate inequalities, you do that for the greater case, which is the greater. So the first one you're going to do as is. So you're going to have x minus 3 is greater than 5. So just drop your absolute value signs. That's all you have to do. Then we're going to write the word or because that's important in our answer. And then we're going to do x minus 3, and we're going to change the inequality sign. So we're going to change it to a less than, and then we're going to switch this to a -5. So we make two changes. With the first one, we make no changes. The second one, you make two changes. So here we'll add 3 to both sides, and we'll get x is greater than 8. Again, or is important in our answer, so keep that. And then we're going to add 3 to both sides here, so we're going to have x is less than -2. So if we're adding 3, we're going to get -2. So this would be, if I'm doing x is greater than 8, it's going to be from 8 to infinity. Or is the union symbol, and then here x is less than -2 would be from -infinity to negative. Okay, this is another example of the greater than symbol. So we're going to have the as is case, the word or, and then we're going to have the case where we change it. So we're going to have 3x plus 2 is less than or equal to -4. So again, change this and change this. So 3x is going to be greater than or equal to, subtract the 2, we'll divide by 3. So x is going to be greater than or equal to 2/3. Again, keep the word or. We'll do the same thing over here. So 3x is less than or equal to -6. So x is less than or equal to -2. So our translating it into interval notation for the greater than or equal to 2/3, we'll have a bracket on the 2/3 and go to infinity. We'll union that with -infinity to -2. And it is acceptable and possibly even preferred if we had written this one first and this one second. But as long as you have both, I think WebAssign is going to give you credit for both. Okay, here's one to practice if you'd like a practice problem. Okay, when we go to set this up, we're going to do the 3x minus 2 is greater than or equal to 5. Again, this is a greater problem, so we've got the or there. And 3x minus 2 is less than or equal to -5. So change the inequality and make this a negative. So we'll have 3x is greater than or equal to 7, adding 2 to both sides. So x is greater than or equal to 7/3, or here we'll add 2 to both sides again, and we'll have -3. So divide by 3, x is less than or equal to negative 1. So we've got from 7/3 to infinity, or actually in the place of or, we need to write the union symbol. And then here we're going to have negative infinity to negative 1. And that should be your answer there. And that actually takes us to the end of this section 1.8 on inequalities. Feel free to reach out to me if you have any questions, and I hope you have a good day.